So in this lecture, I would like to perform the experiment belongs to the potentiometry. In the syllabus of the T.Y.B.Sc, there are two potentiometry experiments. So experiment 1 is to determine the number of electrons in the redox reaction between ferrous ammonium sulphate and cerric ammonium sulphate potentiometrically. The aim of the experiment is to determine number of electrons in the redox reaction between ferrous ammonium sulphate and cerric ammonium sulphate potentiometrically. So we are doing the experiment of potentiometry. So what are the requirement for the experiment? So we require potentiometer. So this is the instrument, potentiometer. Then we require platinum electrode. So this is the platinum electrode. Then calomel electrode. So this is the calomel electrode. We require 0.1 normal cerric ammonium sulphate solution. So you can see this is cerric ammonium sulphate solution. Then we require given Fe-second solution. So this 100 ml dilution flask contain given Fe-second solution. Then we require saturated potassium chloride solution. So this is saturated potassium chloride solution. And finally we require the salt bridge. So this is the salt bridge. Okay. So to determine the EMF of a cell, we have to construct a cell first. In the potentiometry experiment, we are going to measure the EMF of the cell. We are going to construct the chemical cell. So in this experiment, the two electrodes are given, and the name of the two electrodes are, first one, it is the calomel electrode, saturated calomel electrode, and second one, it is the redox electrode. So first of all, we have to dilute the given solution of the ferrous ammonium sulphate. So let us do the dilution of ferrous ammonium sulphate solution. Let us dilute the given solution of ferrous ammonium sulphate solution up to the mark. So we are going to dilute the solution here. It is diluted up to the mark. So we are diluting the solution of the ferrous ammonium sulphate with the help of the distilled water. So see, we have diluted the solution of the ferrous ammonium sulphate. So let us shake this solution. So this is now the ferrous ammonium sulphate solution. Now let us take the 10 ml of ferrous ammonium sulphate solution in a beaker. 10 ml of ferrous ammonium sulphate solution in a beaker. So take the 10 ml of the ferrous ammonium sulphate solution. So I am taking here 10 ml of ferrous ammonium sulphate solution in a beaker. So ferrous ammonium sulphate contain Fe-second ion. It contains Fe-second ion. So we have taken 10 ml of the ferrous ammonium sulphate solution. In this 10 ml solution, we have to add 1 test tube of 2 normal H2SO4 solution. We have to add 1 test tube of 2 normal H2SO4 solution. So in this beaker, I am going to add, this is now Fe second solution, and let us add here 2 normal sulfuric acid solution. The reaction takes place in the acidic medium. The reaction takes place in the acidic medium. Let us dip the glass electrode into it. Now in this Fe second solution, insert the platinum electrode. So this is platinum electrode. So I would like to insert this platinum electrode and connect to the positive terminal of the potentiometer. It is connected to the positive terminal of the potentiometer. Now, on the left hand side, we have taken the 50 ml of the saturated potassium chloride solution, and the calomel electrode is inserted here. Calomel electrode is inserted here. So this calomel electrode is connected to the negative terminal of the potentiometer. It is connected to the negative terminal of the potentiometer. Now, this is a chemical cell, but now circuit is not completed. So let us take a solvents to insert into the 2 electrolyte solution. Now, this is a chemical cell. The left hand side electrode, it is a calomel electrode. Right hand side electrode, it is a redox electrode, where the Fe second solution we have taken and we have added 1 test tube of the 2 normal H2SO4 solution. So now the experiment, it is the chemical cell, it is ready for the experiment. The instrument, it is showing the reading here, the digital display showing the reading here. You can see the reading should be equal to 0.274. EMF of the cell, it is equal to 0.274. So this is without addition of the titrant solution. In this case, we have to add the cerric ammonium sulphate solution. This is cerric ammonium sulphate, yellow colored solution. Cerric ammonium sulphate, it is an oxidizing agent, and this cerric ammonium sulphate, it is added into the solution of ferrous ammonium sulphate. Because we are performing the titration, we are going to determine the number of electrons in the reaction between ferrous ammonium sulphate and cerric ammonium sulphate. So in a beaker, let us take the Fe second solution and we have to add this ferrous ammonium sulphate solution. Now experimental setup is ready. Let us start the readings. So the zero reading without addition of cerric ammonium sulphate, the zero reading, it is 0.275 volt. Now we have to add 0.5 cm³ of cerric ammonium sulphate from the burette. 0.5 cm³ of cerric ammonium sulphate from the burette into the Fe second solution, and store that solution. So the digital display shows the reading now 0.277. Due to the addition of 0.5 ml of cerric ammonium sulphate, now the reading, it is 0.277 volt. There is an increase in the EMF due to the addition of cerric ammonium sulphate solution. The reaction between Fe second and cerric ion will be takes place. Fe second will be oxidizes to ferric ion, and cerium 4 will be reduces to ferrous ion. Now let us continue this titration by addition of 0.5 cm³ of the cerric ammonium sulphate solution, and let us see the reading here. it is 0.285. It is 0.285. This is the reading for 1.0. Volume of cerric ammonium sulphate solution. The reading it is 0.285 volt. So we have to continue the addition of the cerric ammonium sulphate solution from the burette. The EMF of the solution will be steadily going to be increases, and one stage will be reaches there. The EMF of the solution it is suddenly increases, and that sudden increase in the EMF, that is the equivalence point of this titration. So let us add once again the 0.5 ml of the cerric ammonium sulphate solution. Shake it. Shake the solution and note the reading. The reading for 1.5 ml volume of cerric ammonium sulphate solution, it is 0.297 volt. So in this way we have to add the cerric ammonium sulphate solution from the burette, and we should have to note the readings here. Okay. So step by step we are going to add the cerric ammonium sulphate solution, and the EMF of the solution becomes increases. So in this way we have to take the number of the readings here. After the equivalence point, we have to add the 0.5 ml of cerric ammonium sulphate solution, and we have to take 5 to 6 readings more. When the EMF will be increases rapidly, after that we have to add 0.5 cm cube of the cerric ammonium sulphate solution, and we have to continue the reading, and the difference between the two reading it is not too much. Means practically the EMF will be remains constant, or there is very slight increase in the EMF after the equivalence point. Okay, so once we complete the reading, later on we have to plot the graphs here. There are two graphs are given in this experiment. So in this way we have to take the readings with the help of this chemical cell. One electrode it is a calomel electrode, other electrode it is a redox electrode. The salt grease it is dipped in the two beakers. Calomel electrode it is dipped in the saturated solution. Platinum it is into the FE2 solution, and we are going to be add the cerric ammonium sulphate solution from the burette. The EMF of the solution goes on increasing. So we continue the addition of cerric ammonium sulphate from the burette. There is an increase in the readings. So I have taken number of readings, you can see here. So at 5.0 volume the reading it is 0.404, and at 5.5 volume the reading it is 0.901. So there is a sudden increase in the EMF here. The difference between the two EMF is very large here. So it means that at 5.5 volume of cerric ammonium sulphate, supposed to be we are getting the equivalence point, because there is rapid increase in the EMF. Now let us going to continue the addition of cerric ammonium sulphate. After that also I will shake the solution. So the instrument shows the reading for 6.0 volume, it is 0.966 volt. Let us add once again 0.5 . So for 6.5 the reading is 0.981. Once again continue the reading by the addition of 0.5 ml. For 7.0 volume the reading is 0.988. So in this way we have to take the readings. Okay, after the equivalence point, the increase in EMF it is very slightly, or the EMF should be increases very slowly. And after the equivalence point, we have to take 7 to 8 readings, because we have to plot the graph of EMF versus volume of cerric ammonium sulphate added. So in this experiment, we have to plot the two graphs, EMF versus volume, and second graph it is delta E upon delta V versus the volume.
In this video, I would like to discuss about the experiment belongs to T.Y.B.Sc semester 6th examination, physical chemistry exercise, potentiometry first. The aim of the experiment is to determine the number of electrons in the redox reaction between ferrous ammonium sulphate and cerric ammonium sulphate potentiometrically. So related to the syllabus of the physical chemistry, there are two potentiometry experiments are given. So this is first experiment, potentiometry first, to determine the number of electrons in the redox reaction between ferrous ammonium sulphate and cerric ammonium sulphate potentiometrically. So we have to perform potentiometry experiment. So what are the requirement of this experiment? Potentiometer. So with the help of the potentiometer, we can measure the EMF of the cell. We can measure the potential difference between the two electrodes. Then to construct the cell, we require platinum electrode, calomel electrode, then potassium chloride salt bridge, given ferrous ammonium sulphate solution, cerric ammonium sulphate solution, which is having the concentration 0.1 normal, 2 normal sulfuric acid solution. So these solutions are required to us. Along with this, we require the apparatus, 2 beaker, stirrer. Okay. So let us see how to perform this experiment. So first of all, let us draw the diagram belongs to this experiment. Draw the diagram belongs to this experiment. First of all, construct the cell now. So let us see how we have to construct the cell. See here. So in a one beaker, we have to take 50 cm cube of, in a beaker which should be kept onto the left hand side when we construct the cell. So we have to take 50 cm cube of 0.1 molar KCl, potassium chloride. And in this KCl solution, we have to dip or we have to insert calomel electrode. So calomel electrode is dipped in the solution of the saturated potassium chloride. So this is the construction of calomel electrode. In another beaker, which should be kept at the right hand side, we have to take the given Fe-second solution, diluted Fe-second solution. The volume of the Fe-second solution, it is 10 ml, 10 cm cube. So 10 cm cube of ferrous ammonium sulphate solution, diluted solution. And we have to add 1 test tube of 2 normal sulfuric acid. 1 test tube of 2 normal sulfuric acid. Then insert the platinum electrode in this solution. Platinum electrode should be inserted here. Now calomel electrode should be connected to the negative terminal of the potentiometer, and platinum electrode is connected to the positive terminal of the potentiometer. Positive terminal of the potentiometer, where the potentiometer measures the potential difference between the two electrodes, right hand side electrode minus left hand side electrode, and that is also called as a EMF of the cell. Now in the two beaker we have to dip the salt bridge. What is the function of the salt bridge? The function of the salt bridge is that to make the electrical contact between the two electrolytes. Electrical contact between the two electrolytes. So this is the experimental setup. Once we construct this chemical cell, then we have to start to take the reading. So this is a chemical cell, and this chemical cell can also be represented as in this manner. On the left hand side, saturated calomel electrode, it is connected to the negative terminal, Solbridge double vertical line. In the right hand side beaker, we have to take Fe second solution, diluted Fe second solution, 10 ml Fe second solution, and in that solution we have to add of one test tube of 2 normal H2SO4 solution. Then the platinum electrode is dipped into this solution. This is connected to the positive terminal. So this is the representation of this cell. Diagrammatically, the cell can be represented in this way, and this cell, according to the T.Y.B.Sc, the cell can be represented. This is the chemical representation of the cell. Okay. Now let us see how to perform the experiment. Once we prepare the cell like this, once we construct the chemical cell like this, later on we have to measure the EMF of a cell. Okay, so let us see. Instructions. Dilute the given solution of ferrous ammonium sulphate to 100 ml in a dilution flask. Then pipette out 10 ml of the diluted solution in 100 ml dry beaker. We have to add one test tube of the 2 normal H2SO4 solution. Already I have explained this. In another beaker, we have to take 50 ml of the saturated KCl solution, calomel electrode, it is to be dipped into it. Then connect the two beakers by means of the potassium chloride salt bridge. Connect the calomel electrode to the negative terminal and platinum electrode to the positive terminal. Then fill the burette with 0.1 normal cerric ammonium sulphate solution. Fill the burette with 0.1 normal cerric ammonium sulphate solution and add 0.5 ml of 0.1 normal cerric ammonium sulphate solution from the burette to the beaker containing ferrous ammonium sulphate. Stir the solution and note the EMF of the cell from the potentiometer after stirring. Okay, so we have to add 0.5 ml of 0.1 normal cerric ammonium sulphate solution in the beaker containing Fe second solution. So chemical reaction takes place between these two reactants. In the beaker, we have taken Fe second solution. So the reaction between Fe second, Fe2 plus, it will react with cerric ammonium sulphate, that is cerium tetrapositive ion, cerric ion, and oxidation of the ferrous ion takes place. So it is converted to ferric ion, and cerric 4 plus converted to cerric 3 plus. So this is the redox reaction. Redox means simultaneous oxidation reduction reaction. So in this chemical cell, this reaction takes place at the right hand side electrode, where we have taken Fe second solution. We have taken Fe second solution. So this is Fe2 plus solution, and we are adding from the burette. We are adding from the burette the cerric ammonium sulphate solution. Okay, cerric ammonium sulphate solution. Okay, so due to this, the reaction between these two will be takes place. Platinum electrode is inserted here. So this is the redox electrode, and on the left hand side we have taken the calomel electrode. Okay, so calomel electrode should be taken here. Okay, and this is connected to the negative terminal of the potentiometer, and platinum electrode should be connected to the positive terminal, and salt bridge is dipped, and we have to start the readings here. So in this way we have to take the readings here by constructing the chemical cell. Okay, by constructing the chemical cell. So we can write here EMF of the cell, it is equal to electrode potential of the right hand side electrode minus electrode potential of the left hand side electrode. So right hand side electrode, it is this redox electrode. So redox electrode, it is right hand side electrode, it is a redox electrode, Fe2 plus Fe3 plus redox electrode, ferrous ion, ferric ion, and left hand side it is a calomel electrode. Calomel electrode is used as a reference electrode. Reference electrode is a electrode who is having the known potential. So the potential of the calomel electrode, it is constant, and the potential of the calomel electrode, it is equal to 0.242 volt. Okay, so this value can be kept here. Okay, so in this way we can take the reading for this experiment. With the help of the potentiometer, we can measure the EMF of a cell. Now this is the observation table here. Okay, so we are performing the titration. In the Fe-second solution, we are adding the cerric ammonium sulphate solution. Every time we are adding 0.5 ml, and we have to see what is the EMF when we have added the 0.5 cm cube of that cerric ammonium sulphate solution into the beaker containing ferrous ammonium sulphate solution. So we have to note the readings here. So whatever the reading I have taken, some readings I would like to write here in this observation table. In this observation table, I would like to write the actual readings where I have taken, and I have shown that readings in the experimental part also. So for 0.0 addition of this cerric ammonium sulphate, it is not necessary to take the reading here. Okay, so start from this. This is first reading now. Addition of 0.5 ml. Suppose we are getting the reading here 0.275 volt. Due to the addition of the 0.5 ml cerric ammonium sulphate solution into the beaker, then we have to stir the beaker, and EMF of the cell noted by the potentiometer, it is 0.275 volt. Then second reading now here, after the addition of the 1.0 cerric ammonium sulphate from the burette, it is 0.277. It means that EMF of the cell, it is slightly increases here. Third, after the addition of once again 0.5, means at volume 1.5, the reading becomes equal to 0.285 volt. So in this way we have to take the number of the readings. Okay, we are going to perform here the titration. Cerric ammonium sulphate, it is filled in the burette and in a beaker Fe-second solution, and in that Fe-second solution we are adding the cerric ammonium sulphate, and after every addition of the 0.5 ml of the CAS, cerric ammonium sulphate, we have to note the reading after stirring the solution. And one stage will be reaches there where the readings are suddenly increases. So I would like to write the reading belongs to 5.0 here first. 5.0. Okay, it means it is 10th reading. It is 10th, 5.0. So it shows number of the readings already I have taken, but I would like to write here the reading corresponding to this 5.0 volume. It is 0.404 volt. Okay, and after the addition of the 0.5 volt, that is 11th reading, the EMF of the cell becomes suddenly increases. It is 0.901 volt. So you can see the difference between these two readings becomes very large, and here the difference between the two readings, it is very, very less. So this is the sudden increase in the EMF, and after that we have to take 7 to 8 readings. Okay, 7 to 8 readings here. So in this way we can perform the experimental part here. Then we have to complete this observation table delta E. So this reading minus this reading. So write that will be here. Suppose now in this case it is 0.002 delta E. Delta V, it is the difference between the two volumes. 1.0 minus 0.5, it is 0.5. So it will be same everywhere, 0.5. Similarly here 0.285 minus this. Okay. So it becomes around equal to 0.008. 0.008 here delta E. Then calculate delta E upon delta V, put that value here. Then we have to calculate the reduction potential using this equation. Reduction potential of the electrode. Okay, reduction potential of this electrode. So just adding 0.242 into this EMF of the cell, then we can calculate the reduction potential, and final calculation is log of activity of the Fe2 plus ion and Fe3 plus ion. Okay, activity of this log of. So by using this equation we can do the calculation here. 0.771 minus reduction potential divided by this 0.0592. So in this way we can determine this, because we are going to plot here the graph. Okay, see now here graph. Plot a graph of delta E upon delta V versus volume V. Determine the volume Vx at the equivalence point. According to this, we have to determine the volume Vx at the equivalence point. Now, the nature of the graph will be like this. If we plot the graph in this way onto the y-axis, we have to take delta E upon delta V. Okay, in the observation table already we have mentioned versus volume of cerric ammonium sulphate added. Okay, volume of cerric ammonium sulphate added. So the nature of the graph will be like this. Nature of the graph, it is like this. Okay, approximately it can be shown in this way. So this is the equivalence point here. Suppose that equivalence point it is at 5.5. Okay, so according to this we can find out the Vx, that is equivalence point. Okay, so with the help of this graph we can determine the Vx. Then we have to plot the second graph also, reduction potential versus log of ferrous ion and ferric ion, activity of the ferrous ion to the activity of the ferrous ion. So the nature of the graph will be like this here. Okay, nature of the graph, it is in this way. On the x-axis, take this ratio log of Fe2 plus and Fe3 plus, and onto the this y-axis we have to take here reduction potential. Okay, so the nature of the graph will be like this. Okay, positive reading as well as negative readings we are getting here, and we have to take the slope here. Okay, we have to take the slope here. So you can see slope it is equal to minus 0.05916 divided by n. Slope it is equal to minus 0.05916 divided by n. So n equal to minus 0.05916 or 592 divided by slope. So in this case, as the nature of the graph it is descending, so slope becomes negative here. So negative, negative, positive. So number of electrons which are released during the reaction, the expected answer should be equal to 1. We should have to get the expected answer, it is equal to 1. Because in this redox reaction only one electron it is released or one electron is added in the oxidation in the reduction reaction. So on the same time, with the help of this graph, first we have to calculate normality of ferrous ammonium sulphate solution. Normality of ferrous ammonium sulphate solution. So normality of ferrous ammonium sulphate solution, it is equal to normality of ferrous ammonium sulphate solution. Suppose it is N1. So it is equal to 0.1, that is the normality of cerric ammonium sulphate into Vx divided by volume. We have taken 10 ml here, 10 ml in the beaker, ferrous ammonium sulphate solution. So suppose Vx it is equal to 5.5 here. So we can put that value and we will get the normality here, 0.1 into 5.5 divided by 10 here. So whatever the calculation, we are getting the normality of the ferrous ammonium sulfate solution. And with the help of this second graph, we can determine the number of the electrons released or number of the electrons added. Okay. Now let us see the result. Normality of ferrous ammonium sulfate solution. This we have to write here after the calculation, and number of electrons involved in the reaction. Expected answer should be equal to 1. But by doing the calculation, we should have to get the answer. It becomes equal to 1. So in this way, we can perform this experiment. Okay. We can perform this experiment here. That is to determine the number of electrons in the redox reaction between ferrous ammonium sulfate and cerric ammonium sulfate potentiometrically. So we carry the reaction between FAS and CAS, and only one electron is released, means oxidation of Fe2 plus gives Fe3 plus electron. So N equal to 1 here. So to perform this experiment, we have to construct the chemical cell. One, it is a calomel electrode, and other it is a redox electrode. And by constructing the chemical cell, we can measure the EMF, and that reading should be written here. Okay. So nearly about we have to take the 20 to 25 readings here, approximately 25 readings. Then calculate delta E. Delta V should be same for all, difference between the volumes. Then delta E upon delta V, reduction potential, and this. Okay. So in this way, we can perform this experiment belongs to the potentiometry. The experimental part, it is already done by me. So I would like to show that also. You have to just watch the experimental part belongs to this experiment.